Hello, everybody. Today we are looking at Wegener's puzzling continents. So, what are we trying to get out of this? We want to be able to summarize the cycling of Earth's material through plate tectonics and therefore how conditions on Earth have changed over time. So, we've read about this just a little bit that Wegener was the first person to propose the idea of having continents move or having our plate tectonics. He really didn't know what it was and he didn't really have a specific, like, this is what's going on. But he had a lot of evidence to help point to, I think something's going on here. So first thing, if you have not already done so, please put your name on this paper. And now, and then also do, and then when, what hour you have science class. Now on here, we're going to start at the back and on the top. And yes, if you didn't hear me just separate those two, you definitely can, because we're going to be cutting one of them off of another. So our prep work. Who is Alfred Wegener? What was his job? Where's he from? What did he propose? And what was his claim to fame? Also, what is Pangea and continental drift? Right now, go ahead, take a few minutes to go ahead and grab this information or jot it down. Look at your notes. That's why we took them. That was in our chapter 7, lesson 1. That's where you'd find this information. So pause this video and get that information. If you're still listening and you're like, I didn't even pause the video, pause it now, please. Okay, you got this? I'm hoping you do. So, who was Alfred Wegener? Well, he was a German scientist. He proposed the idea of continental drift. His claim to fame was coming up with this idea of having Pangea, or all Earth, this one giant supercontinent. But did he have any reason to believe it? Like, what was his evidence? Now, it talked about a few different things, like fossil clues, there was glacial grooves, there was also mountain ranges that were matching up. And for a long time, people were like, I think you're completely nuts. They honestly laughed him into oblivion at the time. No one, during his lifetime, no one ever believed him or really bought much into this, maybe other than just like a few other people here and there, but largely the scientific community thought he was a joke. But he had all this evidence, and that's what we're going to be looking at a little bit here today. And as we got more technology, more scientific understanding, more technology to help prove like the different grooves that might be on the mid-ocean ridge, or kind of being able to actually track, are the plates moving? Scientists are like, oh my gosh, this is legitimate, this is happening. So we just said all that information. Jot it down if you haven't. So what we're going to do then next is set this page aside. We're going to come back and answer these questions at the end. So imagine you are Alfred Wegener. Write a 1-paragraph diary on reacting as if you were him to describe why his map is a good map. And then you're also going to come up with, imagine you're a skeptic of Alfred Wegener writing for a German newspaper, the Munich Minute. Write a 1-paragraph statement to criticize Wegener's work. Your criticism must include some challenges about fossil evidence, shapes, and information about Alfred Wegener's training and schooling. We're going to come over here, though, to that page that we ripped apart. And if we also are kind of looking at this one up here. So after coloring our pieces and then cutting them out, carefully tape them or glue them neatly in the correct formation. Match the same fossil types together across the continents to show how many smaller continents were joined into one giant continent. So when we look at this, we're probably noticing that you know a few of these continents already. Now, I will tell you we are missing a few continents because our paper is only so big. So we just have these ones to get us started with, but let's use these. So the first one, this kind of edge space, this is the continents are all surrounded by something called a continental shelf. It's like this stippled pattern, and it extends beyond the continent until there's a large change in the slope. So really, it's kind of just like, if you've ever been on like a sandy beach, you know, as you walk out into the ocean, the water starts to get deeper because like there's a slope. That's what it is. So the sand is large. It's kind of loose. It's there, but it's something that's easier to move and erode around. Then we want yellow. So about 300 million years ago, a unique community of plants had evolved, known for the European flora. Fossils of these plants are found in Europe and other areas. So color the areas which we found these flowers. So we're looking for that one, and so we've got some over here. Now I'm just giving it a pretty quick color in. I would expect yours is going to look much nicer. We've got some there though. And that could be the only place because that's going to match up with places in Europe, like it said. Our next one, we need green. Fossils of the fern Glacioperis have been found in these locations. Glacioceras had very heavy seeds that could not move by wind. Color those areas green. So we're looking for this type of leafy one. Now I see some here. I see I got a little bit here. I see I've got a little bit here and over here. Over here. Okay, and again, color yours in a little bit nicer. I'm trying to do a quick job here. Fossil remains of the half-meter-long freshwater reptile called Mesosaurus had limbs for swimming, but could also walk on land. Other evidence suggests that although they lived in water at times, they were not strong swimmers. Color the areas where these fossils were found. So we need to look for him, and he's right here. And he's over here. Then fossil remains of Cygnothoris, land reptile approximately 3 meters long that lived during the early Mesozoic era, about 230 million years ago. It was a weak swimmer, so we need that guy. And there's kind of two of them, so you got to be careful of who you get. We want this one. The other one kind of has like a square head. That's kind of how I keep them separate. The one that doesn't have the square head. And then our last one is going to be in brown. And yes, please use the correct colors for this just so we can make sure we match up all the right things. So fossil evidence of the early Mesozoic land-dwelling reptile Litosaurus. They reproduce by laying eggs on land. In addition, their anatomy suggests that these animals were probably very poor swimmers. Color these areas brown. So we've got some up here and over here. Oh, and there's a little bit over here as well. Okay, so now you're going to go through and cut these out. I'm going to cut out just at least 2 of these pieces to get us started to kind of show you what's happening. Now, if you finish this and all of your pieces are not matching up, then you're not done. Because all of the pieces, now remember that continental shelf I talked about? That continental shelf, that will overlap, or that might need to be moved a little bit here and there, because that can be moved around fairly, well, at least as far as plate tectonics, a little bit more easily. So there, what continent do we look like? Miss Zahner will be happy with you if you know that that's a continent, not a country. Fun fact, if you said Africa, nice job. Nice job. So go ahead, cut these out. If you need to pause this video at some point, I'm trying to give it a real quick one so you don't have to listen to me cutting forever and ever and ever here. And as you are seeing me cut these, you can already start to see like, which areas might line up versus which areas might not line up. Hint, hint, yes, the continents themselves are a bit of a puzzle, and they fit together, but then all of those fossils must fit together. And as I'm cutting these, I've just got one more left to do, so I'll do it real quick. Okay, and we got one last one. So the one that early map makers and probably you discovered when you were in like preschool was that Africa and South America look like they fit together, which in fact they do. Now, if you wanted to go through and cut off the continental shelf a little more so that these match up, by all means, go for that. But we have these two that are matching up. And those shorelines match up pretty darn well as well. Do not glue these until you've got all of the bits and pieces done, because I have people glue them and then they don't have enough room. I always have a few students that they will go like this and then think, oh, I'm done. But they're not. We're missing a piece here. Okay? So make sure these are your 2 pieces I'm getting you started with. Make sure you get all 3 of these pieces also added in, because those are all part of the continents. Also, this is not the correct answer, just putting this green. You've got to get these 3 to also match up over here, and then you're going to glue them down. Okay? Now, as we were reading over these things, there were things on here. This was a weak swimmer, this animal was. This one was a strong swimmer. This plant had seeds that were very heavy, and they would not have moved by wind. Yet, when we find these 2, these green ones, this is Africa and South America. That's an entire ocean apart. There is no way that that seed could have made it all the way across the ocean, because this is talking about before ships or before people, right? And again, we're talking about the theory of evolution, not that it's necessarily we're saying 100% it's true, but just as there's evidence to support it. And being in science class, that's what we're learning about, is just what is that evidence that supports it. So on the back side here, where it says, imagine you're Alfred Wegener. Write a 1-paragraph diary entry acting as Alfred Wegener to describe why you think that your map is a good map. Use evidence. What did we just talk about? What are some reasons? Maybe how did some of those continents line up? What were some of those facts that we said about some of those different plants and animals that make this a good map, or kind of help to prove that? Use details, use evidence. The big thing, imagine you are Alfred Wegener. The best answers that come in are like, hello, or dear diary, I just got back from a day of exploring and da 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 da. And then, like, you know, maybe he wrote certain things in his journal, or he wants to tell his journal or his diary about different things. Write it as if you're at Alfred Wegener for all the credit. You're just like, this is a good map because of these things. No, get to be a little creative here. Now, the second one, imagine you're a skeptic of Alfred Wegener writing for a German newspaper, the Munich Minute. So, what are some things about why you think this is not legitimate? These are things, why did people laugh at him? Why did he think this was ridiculous? Now, you could almost use some of this information, like at the time, maybe they are thinking that, you know, hey, this, if it's got limbs for swimming, it should be able to swim. Even though we're like, okay, an entire Atlantic Ocean is probably not going to be good for basically anything if it also lives on land at some point of its life. But this is where the skeptics come into play. Maybe you are a skeptic, so you can use some of your information. But again, imagine you are a skeptic writing for the Munich Minute. So it might be like, Miss Morotic writing for the Munich Minute. Have you heard about the crazy person in town and what he thinks? Blah, 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 blah. I'm going to stop there so I don't give you a complete answer there. But full credit looks like answering this as if you are a reporter for the Munich Minute. As always, if you have any questions for any about this assignment or anything of that nature, please let your science teacher know. Check Google Classroom to see if there's any other directions. Otherwise, have a great day, everyone.